The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 1, Historical. Section 8, First Glimpses of Non-Euclidean Geometry. Saccheri. Among the early postulate-demonstrators, there stands a unique figure, that of the Jesuit Gerolamo Saccheri, 1667 to 1733, contemporary and friend of Ceva. The man devised an entirely different mode of attacking the problem in an attempt to institute a reductio ad absurdum. At that time, the favorite starting point was the conception of parallels as equidistant straight lines. But Saccheri, like some of his predecessors, saw it would not do to assume this in the definition. He starts with two equal perpendiculars, AC and BD, to a line AB. When the ends CD and D are joined, it is easily proved that the angles at C and D are equal. But are they right angles? Saccheri kept an open mind and proposes three hypotheses. 1. The hypothesis of the right angle. 2. The hypothesis of the obtuse angle. 3. The hypothesis of the acute angle. The object of his work is to demolish the last two hypotheses and leave the first, the Euclidean hypothesis, supreme. But the task turns out to be more arduous than he expected. He establishes a number of theorems, of which the most important are the following. If one of the three hypotheses is true in any one case, the same hypothesis is true in every case. On the hypothesis of the right angle, the obtuse angle, or the acute angle, the sum of the angles of a triangle is equal to, greater than, or less than two right angles. On the hypothesis of the right angle, two straight lines intersect, except in the one case in which a transversal cuts them at equal angles. On the hypothesis of the obtuse angle, two straight lines always intersect. On the hypothesis of the acute angle, there is a whole pencil of lines through a given point which do not intersect a given straight line, but have a common perpendicular with it, and these are separated from the pencil of lines which cut the given line by two lines which approach the given line more and more closely and meet it at infinity. The locus of the extremity of a perpendicular of constant length, which moves with its other end on a fixed line, is a straight line on the first hypothesis, but on the other hypotheses it is curved. On the hypothesis of the obtuse angle, it is convex to the fixed line. On the hypothesis of the acute angle, it is concave. Saccheri demolishes the hypothesis of the obtuse angle in his Theorem 14 by showing that it contradicts Euclid I, 17. That the sum of any two angles of a triangle is less than two right angles. But he requires nearly 20 more theorems before he can demolish the hypothesis of the acute angle, which he does by showing that two lines which meet in a point at infinity can be perpendicular at that point to the same straight line. In spite of all his efforts, however, he does not seem to be quite satisfied with the validity of his proof. And he offers another proof in which he loses himself, like many another, in the quicksands of the infinitesimal. If Saccheri had had a little more imagination, and been less bound down by tradition, and a firmly implanted belief that Euclid's hypothesis was the only true one, he would have anticipated by a century the discovery of the two non-Euclidean geometries which follow from his hypotheses of the obtuse and acute angle.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.